Okay, good morning, physics. So for your warm-up, you're being asked to look at 33, 34, and 35. So let's go through these. So for 33, where's the magnitude of the vertical velocity component the largest? Well, that's where the slope of this line is the steepest. So where is it the steepest? Often students say, oh, between A and B. But what about D and E? Which of those is steeper? I know this one's positive, but which one's steeper? It's D and E. So the vertical velocity is the greatest actually here. Where's the magnitude of the horizontal velocity component the largest? Well, it's actually the same everywhere. This picture is a little misleading as it doesn't show the ball at equal intervals, but if it did, you would see that the ball travels the same distance horizontally every interval, every second, every fraction of a second. It's always traveling the same distance horizontally. The only thing that's changing is the vertical position, and that's because of the acceleration of gravity. There is no acceleration in the horizontal direction when we think about projectile motion because we ignore something. What do we ignore that would normally slow us down? Friction. Moving on. C. Where's the vertical velocity the smallest? Well, that's basically asking where is the ball traveling flat horizontally. And so where is that? Here, 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 here. It's there. In between B and C, the trajectory, the path that the projectile takes is flat. And when it's flat, the vertical velocity is 0. Just like when you throw something up. When it gets to the top, its vertical velocity is 0. It's stopped moving up and down. Okay, D, where's the magnitude of the acceleration the smallest? Well, once the cannonball leaves the cannon, and that's the part of the timeline we're talking about, there's only one thing accelerating the cannonball. What is it? That's right. It's gravity. Is gravity different here at A than here at B? Hopefully you said no. Is it different here at C? No. D? No. E? No. Gravity is the same the entire time. So the acceleration is always the same. It's negative 9.8 meters per second, negative because it's down, 9.8 meters per second because that's what it is. And that's it. For 34, we've got a person playing with a car and it flies off the balcony. Well, the answer is no. And to understand why, you can see page 148, figure 6.1. Take a look at that. Let's see. 35, airline pilot drops a crate. Ignoring air resistance, where will the plane be relative to the crate when the crate hits the ground? So it would look like this. I actually forgot to draw the ground, but imagine the ground is right here. So the plane drops the crate. The crate is always going to stay right below the plane because they start off with the same horizontal velocity because the crate is inside the plane. It's moving together. And when it drops it, as long as there's no air resistance, no friction, and we've been told to ignore that, it's going to fall directly below it. Now, things that are very aerodynamic actually do this even though there is friction. For example, take a look at this. This is a B-52, which is a bomber, dropping 45 gigantic bombs. Notice that this area right about here is straight down. So if you can see the bombs right down there as they fall, that'll mean that they're staying directly below the airplane as it flies. There they go. Notice where they are. Hard to see, but they're right there. And you'll see the explosions on the island starting now. So, what does that show us? Well, that shows us that even though there was some air resistance, we can see that these explosions are occurring pretty much right underneath the airplane. That means that the bombs were falling and basically staying right underneath the airplane. They weren't slowing down. They were just falling down faster and faster. Why? The x velocity doesn't change because there's no acceleration in the horizontal direction. The only acceleration is in the y or vertical direction, hence this parabolic shape. So there you go. That's the warm-up. Hopefully it all made sense.